Okay, 13.7, applications of quadratic equations. Basically, you know what application means? It means word problems. Okay, we're going to use quadratic equations to solve application problems. Use these types of equations to solve problems involving consecutive integers and also the Pythagorean theorem. Okay, attack plan for application problems. Okay, literally just read the problem carefully, maybe twice, maybe more. Okay, decide what's asked for, assign a variable or variable expression to the unknown quantities. Okay. Form and then solve an equation that relates to the form provided. A form of some type may be necessary, like the Pythagorean theorem, or like maybe area or perimeter. Check your solution with the wording of the problem to make sure it makes sense. Kind of intuitively, does it make sense to you? Okay, the first one here I kind of just left in their way, then we'll do the factoring part ourselves. Okay, let's read here. One number is 4 more than another number, and the sum of their squares is 296. What are the numbers? Okay, let's decipher how they decided this. Okay, let's come back to the pilot here. Okay, one number, okay, is 4 more than another. Well, what's that number? Does it give it to us? Okay, and ask yourself these questions. Does it give us the number? Well, no. So let's let it be, that's what I'm saying, let x be the smaller number. Let it be our variable, okay? And that number, okay, is 4 more than another number. Well, what's the other number? It's the larger number. And then they add 2. Well, what's the sum? The sum of their squares is 296. Notice it's the sum of their squares. Okay, that's what we got to look for here. Squares. Notice it says here, be very careful. And then what are the numbers? And then it gives us this. So we'll come in here and we'll rewrite this equation here. Let me see if I can just go and copy it. Yes, I can. And we'll copy it over to the next page here. Okay, copy. Go to the next page here, and then we'll copy this, and then we'll go ahead and just factor it. Okay, so we've got this form here. Okay, so we've got x squared plus x plus 4 squared. Remember that whenever we have something like this, when we have a power of 2, but we've got this plus, we can't just suddenly just jump in and start distributing that power of 2. We've got to come in here and go ahead and write this as x squared plus x plus 4, all equal to 296. Okay, well, notice here I'm going to go ahead and FOIL this guy out. Okay, so then I'm going to have x squared plus, well, I'll have x squared plus 4x plus 4x plus 16. And let's go ahead and get this guy over right now. Okay, let's go and get him to the other side. So then I'll subtract 296 here, okay, from both sides, and that's going to give me minus 296. Okay, well, let's come in here and start combining like terms. Notice I have x squared here. Well, that's going to give me 2x squared, okay, and then I've got 2 x's here, and that's going to give me plus 8x, and then I have 16 minus 296, and that's going to give me minus 280. Okay, well, let's look very carefully at this. All of this has to be equal to 0. Don't forget that. Okay, notice I can go ahead and pull out a 2 though. Okay, when I pull out a 2, I'm going to be left with x squared, okay, plus 4x, and then divide that by 2 and you get 140. Okay, so minus 140. Okay, all of this equal to 0. Now we're going to have to factor this guy. And unfortunately, we've got a pretty large number here. So we've got this negative 140. And you can play around with, excuse me, you can play around with some numbers. I'll just jump in and show you that you're going to end up having 10 and 14. And then you have to decide which is going to be where, because since I've got a negative here, I accidentally put that there. Okay, you've got 10 and 14. Which one's going to be your negative? Which one's going to be your positive? Well, notice if I have this negative 10, okay, but then I add 14 to it, I will get this positive 4 here. So then I can go ahead and come in here and go, okay, well, I've got 2, okay, I'm going to have 2 x's here, okay, and then I'll have a negative 10, and then I'll have x with a positive 14. Okay, and remember, these are commutative. You can put them either which way, and really there's no rhyme or reason with me. Maybe there should be, but I don't really try to worry about it too much. Okay, well, now we're going to make this all equal to 0, and we can figure it out. So keep your 2 out here, okay, he's out here, but you don't have to make him equal to 0, but you don't need to include him, okay? So then you're going to have this x minus 10 all equal to 0, and then you're going to have x plus 14 all equal to 0, which is going to give me x equals 10 and x equals negative 14. Okay, so there's two answers to this problem, okay, which it does give it to him. So there are two sets, which is going to give us x equals 10, okay, and 14. But we need to go back in there and check and see if which one works. And when we look back up here, we can plug x back in and notice that x, okay, well, we plug in, you can't have the negative. So when we plug in x, okay, we got x is going to be our smaller number. But when we add 4 to that, x plus 10, x plus 4, we get two numbers of 10 and 14. And you can plug these back in and they work out great. Okay, so let's come back over here. We'll start on some more. Okay, in an orange grove, there are 10 more trees in each row than there are rows. How many rows are there if there are 96? Okay, so we're dealing with an orange grove. Okay, so we have something that looks like this. Here's our grove here. Make a very small grove. It's going to have rows and columns, okay? But think about this. It's saying there's 96 trees in the grove. That kind of sounds like area. And area always goes with length times width. Except here we're going with rows. So if I've got rows here, but then it says on one side there's 10 more trees in each row, so couldn't I conceivably put r plus 10 there? Well, notice this gives me an area that equals 96, and if we plug this in correctly, we can get r plus 10 equals 96. Go ahead and distribute that r, okay, and we get r squared plus 10r. Well, let's subtract the 96 from both sides. Okay, and we get 96 is all equal to 0. And then we can go ahead and start our factoring process here. Okay, so let's come over here and try to find, we've got negative 96 as our factor here. And we need to find some sort of number of 96 that will also add to and create our 96 and also give us 10. And if you look here, we can have 6 and 16. Mind you, I have notes. You're going to have to play around with these. Sometimes you're just not going to just see it right away. Even I don't just see them right away. So don't think that I'm just like some sort of like super genius. I promise you, I am not. But now we have to decide which one's going to be positive, which one's going to be negative. Well, notice here we've got a negative here. So if I do negative 16 plus 16, that will give me, okay, my 10 here. And notice since we have a leading coefficient of 1, we can literally just write this as r minus 6 and then r plus 16 all equal to 0. When we solve, we get r minus 6 is equal to 0, r plus 16 is equal to 0, and then when we solve, we get r can equal 6 and negative 16. Well, let's just be honest, the negative 16 doesn't make any sense. So, how many rows are there if there are 96 trees? Well, r is going to equal 6 rows. And that's how we figure it out. Okay, so let's continue on. Here we're going to look at some definitions here. Integers are consecutive if each is one more than the previous integer. 3 consecutive integers can be represented as n plus 1, and n plus 2. For example, 5, 6, and 7, where n is 5. Well, 5 plus 1 is 6, and then 5 plus 2 is 7, and you can go on and on and on with that. Okay, let's look at another one. Even integers are consecutive if each is 2 more than the previous integer. 3 consecutive even integers can be represented as n plus 2, and n plus 4, where n is an even integer. Notice, 24 could be my first one. Well, 24 plus 2 is 26. 24 plus 4 is 28, and so on and so forth. Okay, let's come over here. Odd integers are consecutive. Each is 2 more than the previous odd integer. 3 consecutive odd integers can be represented is exactly the same way as the even. So it's really nothing more to memorize here. Just notice the number we're starting with is odd. Okay, this is just something good to know. n plus 2, and n plus 4. Okay, so let's look here. Note that the consecutive even and odd integers are represented the same way. The value of the first integer n determines whether the remaining integers are even or odd. Okay, let's look at this one. Find two consecutive positive integers such that their sum of their squares is 265. So we have two consecutive integers. Okay, we know what that means now, so let's come in here and write them out. I've got one integer that's an n. Okay, n. Okay, that's going to be my first guy. Okay, n plus 1 is going to be my second. Okay, it said find two consecutive positive integers. Okay, now such as the sum, well, I'm going to sum these guys, of their squares is 265. So what this is saying is I need to find something that looks like this. N squared plus n plus 1 squared equals 265. Well, we saw one just like this almost at the top. So I'll go ahead and take this guy and I'm going to write this as n squared plus n plus 1. N plus 1 equals 265. Foil this guy out and you're going to get n squared plus 2n plus 1 equals 265. Subtract off the 265 from both sides. Okay, I'm going to go ahead and start combining as I go forward here. N squared and n squared is going to be 2n squared, okay, plus 2n, okay, and then you got 1 minus 265, which is going to be, minus 264, all equal to 0. Okay, notice I can factor a 2 out of this. Factor 2 out and I get n squared, okay, plus n, and then 264 divided by 2, just real quick on the calculator, is 132. Could have done it in my head, but I don't want to waste a lot of time here. It's going to be minus 132, all equal to 0. Now we need to come up with a factors of 132 that will also get us back to 1. Okay, when you end up doing this, you're going to find that 11 and 12 are factors that will work out perfectly. And then we just got to look at it and go, okay, well, how do I get that to 1? Well, how about we have a positive 12 and a negative 11, because 11 from 12 is going to give us 1. And so our factored version of this is going to be 2 n minus 11 and n plus 12. Okay? All equal to 0. Okay? So now what we need to do is come here and go, okay, well, how's this going to work? Well, we need to solve. When we set these equal to 0, we've got n minus 11 equals 0. N plus 12 is equal to 0. We're going to get two answers here. We're going to get n is equal to 11 and negative 12, which we know the negative 12 we can't use. But now we can take this 11 and go, well, my factors are going to be 11 and plus 1 is going to be 12. So those are going to be the answers to this problem right here. Okay, let's do one more using a different type of problem. Pythagorean theorem. In a right triangle, if C is the length of the hypotenuse, which is right here, okay, that's the hypotenuse right there, A and B are the legs. Okay, sometimes you also see it's written this way, A squared plus B squared equals C squared. Okay, you can write it either way. Okay, so let's look at the problem. A support wire is 25 feet long and stretches from a tree to the point on the ground. The point of attachment on the tree is 5 feet higher, okay, than the distance from the base of the tree to the point of attachment on the ground. How far up the tree is the point of attachment? Well, they've already given us a nice little problem. A picture here that we'll look at. Notice, okay, if I kind of draw this out here, this creates, I'm going to draw a little line here, okay, which is representing that length. This gives us, okay, a right triangle with side lengths A, B, and C. And if we're going to put this in the Pythagorean theorem, we got A squared plus B squared equals C squared. Let's just plug in all our points into that formula. Well, you can make A or B whatever. So here I'm going to have x squared plus, Well, my next part's going to be x plus 5 squared equals, well, this right here is going to be 25 squared. Okay, let's come back in here. Let's start kind of simplifying this. We got x squared plus x plus 5, x plus 5, all equal to 25 squared is going to be 625. Okay, continuing on, I got x squared. Well, notice here you're going to end up having x squared plus 10x plus 25, all equal to 625. And since we're dealing with a quadratic, we need to make sure this is equal to 0. So we're going to have 2x squared, okay, plus 10x, okay, and then we got 25 minus 625. We're going to subtract 625 from both sides. Okay, well, that's just going to leave us with 600. Okay, a negative 600, all equal to 0. Okay, notice here that I can go ahead and pull out the 2. Okay, when I pull out the 2, that's going to leave me with x squared, okay, plus 5x minus 300. And then I need to go ahead and find me factors of 300 that will come out to that 5. So coming over here, I put down my negative 300, come over here, and notice you can have 15 and 20. Okay, but we're creating a positive 5 here. So since this is going to be a positive 5, I want my larger number to be the positive number. Okay, so I'll put this positive 20 there, negative there, because 15 from 20 is going to give me the 5. And so I can come in here and go, okay, well, this is going to be 2, x minus 15, and then x plus 20. Oops. Okay, when we set this all equal to 0, okay, we got x minus 15 is equal to 0, and x plus 20 is equal to 0, and we get x is equal to a positive 15 and a negative 20. And know that, look here, negative 20 does not make any sense, but your 15 does. So we know, and I'll put this in blue here, okay, the length that we're looking for is going to be 15. So it's going to be 15 feet. And there's our word problems for application of quadratics. And just like I said, just kind of read them carefully. It does help to use the tutor button if you have that, and just kind of just work your way through it.